instrument transformers by Prospective as a basis of smart grid. So the contents of this presentation, it would have around 6 points. And first of all, I would like to speak about the smart grid from the instrumentation point of view, of instrument transformer manufacturer. Then briefly about ISC 61850 standard, the fiber optic instrument transformers produced by Prospective company, and the vision of Prospective on transfer to smart grid, about some projects deployed here in Russia, and about cooperation opportunities. So first is smart grid from instrumentation point of view. Well, we have there are several problems we foresee when we go into smart grid that would definitely influence the instrument transformers. First of all is that we have more and more secondary devices. Well, for example, if we speak about the substation, about some high voltage substation, then we have probably protective relays, the bay controller, the revenue meter, the power quality monitoring unit, and more and more devices that we should connect to secondary windings of the instrument transformers. This finally makes it almost impossible to connect all these devices, because the more devices we have, the more secondary windings we have to have. And this is a real issue for today, for example, for Russia at least. Secondly is the HVDC projects deployment. At the moment, the only way to make revenue metering for these HVDC projects is to set the revenue metering on the AC side, because it's high voltage and it has big currents there, so we cannot connect the meter directly, and we can't provide the essential accuracy level. So this is another challenge that we foresee, is to organize the AC metering on the high voltage side. Secondly, what I would like to speak is the IC 61850 standard as the basic standard for interfacing smart grid projects. At the moment, we see that the migration to digital communications, the power energy, is inevitable. And if speaking this way, there is no real alternative to IC 61850 standard, the standard that covers overall possible communications in the substation. So this is the standard that we have to study. I say so because it's pretty complicated. It is a big standard, and at least 3 protocols there. Also some additional points, and actually we must understand them precisely to use this properly, because otherwise we won't be able to gain all the potential benefits of the standard. Briefly about the standard itself. First of all, it has overall information models and standardized semantics for functions, for devices, and so on. This is actually one of the crucial points and one of the biggest advantages of IC 61850 compared to other communication standards and protocols in power energy. The standard describes protocols for communications, including real-time application communications. This means that if we compare IC 61850 to some previous standards, we didn't ever have had this standard for inter-bay communications, the real-time communications. It means that if we take two protective devices and we need to establish communications between them using the binary contacts, we could not interchange them with digital communications. But IC 61850 enables us with this option. But the problem is that we don't have enough experience so far. So sometimes we make mistakes, and sometimes in order not to make mistakes, we just wait, put hold on mode, and wait for somebody to make it for us. Third point is digital description, digital format for the projects. This is actually another crucial point of IC 61850 is that we can make the project in digital format and then just use this file in order to transfer parameters and to configure all the devices in this project. So we don't need to make a lot of paperwork, and during this transfer of this data from the project to the parameters, we don't make mistakes, because this is the only one file that we use both for project and for commissioning. And finally, this standard enables us with communications using the state-of-the-art technologies. Of course, I'm speaking about the communication technologies first of all. But still, there are concerns about the reliability of these projects. IC 61850 ideally fits fiber optic instrument transformers, and that is what I would like to show using this slide, is that unfortunately I cannot use my mouse, but to the right you can see the picture, and we can see the FOCT, which stands for fiber optic current transformer. There are two of them. We can see meter, transformer and differential protection, transformer backup protection. You can see the merging unit, which is the analog to digital converter with IC 61850-9-2 interface. And we can see the feeder protection unit. So all of these devices are communicating with each other can communicate with each other using only digital communication protocols. This blue line stands for IC 61850-9-2 protocol, which makes it possible to transfer sampled values of current and voltages to secondary devices like meters and protection devices. And the green lines stand for goose messages, which is another protocol used for transfer of binary signals between devices. So all these communications are possibly made through a single wire. It means that's not actually a wire, it's the information wire. It could be just like fiber optic or copper UTP cable. So this is the Ethernet network, and all these devices connected to this network, just like personal computers in the office. And they establish communications using digital protocols like IC 61850-9-2 and 8-1, which is for goose messages. So it's time to go to fiber optic instrument transformers produced by Prospective company. There's a series of products. The product line consists of two types of high voltage sensors, and then several types of so-called the open loop sensors. So the fiber optic current transformer consists of, you can see it to the left with the red column, the red isolator. The second is fiber optic voltage transformer, the high voltage fiber optic voltage transformer. The electronic modules that are used to interconnect the sensor, the transformer installed at the switchyard, and all the secondary devices. And these electronic modules, they have this IC61859-2 interface. And also you can see to the right is the open loop AC current transformer. This one can be used for sensing the AC current and interfacing with the protective relays or with revenue meters, which of this type. And it looks just you can see that it is much lighter than the normal current transformers that are used in the industry. So if you compare this weight, it would be some 5 or 10 times lighter than conventional oil-insulated instrument transformers. Second point, what I must say, is the primary rated current. Although there is such parameter as primary rated current, but when we speak about the fiber optic instrument transformers, one of the advantages of them is that we can use them for some range of rated currents, not for some certain, 1,000 amps, but for some range between 1,000 and say 5,000 amps, and then they would still be within the accuracy class. Why is it so impossible? Why is it so important? The main thing about this is that if we speak about the rapidly growing power markets like India, and I have looked through the presentation of Smart Grid Roadmap in India, and I saw this, that during the past decade India's demand has grew around 2 times, I think, and it's going to grow and grow within 10 to 15% per year. This finally means that the rated current is constantly growing, and that is why today we have to install some instrument transformers with a rated current, say 1,000 amps, but in some 5 years they would work with some 2,000 or 3,000 amps rated current. So we must, but we must provide this instrumentations within accuracy class, and that is why this is really important. So the accuracy class, by the way, are also shown on the slide, and we have 1.2S for metering protection class and 5 TPE for protection. Also, we can have different, as I said, we can have the fiber optic sensor for DC and AC current that is open loop sensor. The main thing about this sensor is that it actually could be wound around some insulator, around some construction like shown on the slide in the center, and it can really has an open loop, so you don't have to dismantle the current carrying bus. You just have to wind this optical fiber cable and around this bus, and that's all. So if we are speaking about the DC current sensor, then you can see this enormously big rated primary currents, which is 20,000 to 300,000 amps. I would just briefly say that this is actually rather specific use case. This is a specific market of aluminum melting facilities, and they really have these enormous currents of 200,000 amps and so on. But at the same time, we can have this normal currents for HVDC installations, and it will also suit. Then the second is the open loop current transformers for AC. You can see that it works with the lower lower rated currents. Is from 5,000 amps to 180,000 amps rated current. The secondary interface of these two types of current sensors is for the DC is frequency output, the analog current output, the pulse output, and RS485 Modbus protocol output. And for the AC current sensor, it's just a standard 1 amp analog output or IC61859-2 protocol interface. And the weight is pretty small, really small compared to any kind of current transducer. It's only 11 kilos. That's the sensor part. The voltage transformer is actually, may say, an electronic optical voltage transformer. It consists of the high voltage terminal and the capacitor divider inside the support insulator. So this column is actually the capacitor divider. Then we have what is special about this capacitor divider is that it has the A and D converter installed on the base of this divider. So there is a special small electronic module hidden in the base of this device, and it has the digital output that interfaces with electronic module. What is very special about this device is that it doesn't have any secondary windings except for the optical fiber. And you would probably ask, how do we how do we power this electronic A&D converter? And this is what is new about this device, that we use only optical fiber, and we use special laser which is installed in the electronic module that feeds up with this light the electronic module. So it powers this electronic module only with light and nothing else. So you can see the advantage, and this advantage is actually just like the advantage of optical current sensor, is that no electromagnetic interference could influence the signal. So the signal is absolutely clear of any kind of oscillations and stuff from the outside. It's only the pure signal of current and voltage sensed by the sensor and nothing else. So it's completely precise, and well, it's almost impossible for the, may say, for the protection devices to catch some you know, some impulse and make some false trip. Nothing, just a pure signal. The characteristics of this device, we basically have 110 and 220 kilovolts. Well, if we speak about the rated voltages in India, as far as I know, you must have some maybe 133, and it's absolutely acceptable. It has digital interface with IC61859-2, just as previously mentioned current transformers. It also has an optional analog interface, which is 100 volts divided by square root of 3. Its accuracy class for metering is 0.2 and for protection is 3p. And its weight is it's a little bigger than optical current transformer, but if you remember the weight of the conventional voltage transformer, the oil insulated voltage transformer, then it's much and much lighter again. The application areas of these devices are shown on the slide. That's basically the most power-consuming industries and the power energy facilities itself. These power stations, substations, HVDC lines, the industries, and electrified transport. So the fourth part of this presentation is a step-by-step transfer to smart grid using these fiber optic technologies. What we can provide today, what we can make today is, for example, start with a revenue metering project. The fiber optic current transformers and fiber optic voltage transformers are very, very compact and light. So they are basically, they could be installed even on some existing substations in series or in parallel with the equipment already installed there. Or if we speak about the new substations, then we can use them and make these substations much more compact and small. We have this, you can see on the slide that we have some groups of fiber optic CTs and fiber optic VTs. They interface with the electronic modules installed in the control room of the substation. And we have only fiber optic cable between them, no copper wires. And then these electronic modules organize this so-called the process bus, the IC61859-2 LE interface that can be used both with the revenue meters, with protection devices, and so on and so forth. So then, if speaking about the revenue metering system that is proposed to be organized as the first step, we make this revenue metering, and we can make it already. We have a special revenue meters with digital interface. They're actually produced also in Russia, but normally there are several revenue meter manufacturers who support IC61859-2. And we can integrate this into smart metering system using some different protocols, and we can also establish the power quality, which is also possible with this fiber optic CT and VT. We can monitor power quality in accordance with the IC and EAN standards. Step 2 is fully digital substation, when we use not only metering but all the protection schemes and automation. Everything is built based on the digital process bus, the IC61859-2. So in this case, if I go back and refer to this slide, you can see that we have only 2 electronic modules installed. One is for current transformer, second one is for voltage transformer. And referring to the second slide, to the next slide, you can see that there is more of them. We add one for protection, and we would probably add another one for redundancy protection, but we don't need to install any more primary sensors. So we just install these 3 phases of current transformers and voltage transformers. So we just add up some electronic modules in the control building. And in this case, we have the interface for everything, just for any secondary devices like protective relays, like some control automation, like, as I said, the power quality monitoring and revenue metering. Just a second, and I must actually say that this stuff is pretty new. I mean that there's not yet that much manufacturers of the protective relays of revenue meters with IC61859-2 interface. But what really Prospective did in, for example, in Russia, it could, unite different manufacturers, and some of them are even competitors between themselves. Actually, everybody started developing IDs with IC61859-2 support. There's basically some companies like ProSoft Systems, the Acro, the Bressler company, and different Russian ID manufacturers who, in some period of 2-3 years, have really integrated support of IC61859-2 interface. And actually, the second step in this cooperation goes to the integration of all this equipment and making some commissioning and design stuff. So this, in this sphere, there is also several companies working on this, and like, for example, Techwell company. Point 5 is reference applications. I would like just to show you that are made in Russia. Well, starting, I don't know, let's start just from the left upper corner. It's pilot 110 kV digital substation in Russia. When you can see on the slide, there is a picture with fiber optic CTs and VTs installed on the substation. And it's actually, as I said, it's pilot, so-called digital substation. This is like an R&D center where people do some tests, and they check this work of IDs, of protection, of metering, and so on and so forth. Second installation is steam power plant, and remember I promised you to speak about the use of this open loop AC current transformer. So this is the reference installation on the Moscow power plant, and the instrument transformer with the analog interface, so it makes some digital to analog conversion, and it is connected to the revenue meters, so they organized the revenue metering based on fiber optic instrument transformers. And what is good about this installation is that if this was just a conventional instrument transformer, then the commissioning staff would probably have to dismantle all the current carrying bus. But in the case of fiber optic instrument transformer, the only thing was just to wind the fiber optic around this insulator, and that's all. That's all installation. Next project is digital revenue metering project in Kazan, and which has been commissioned just a couple months ago. So this is a real substation, where this equipment is installed, and it is going to be used for, on the first step, just for revenue metering, but they have very broad plans on adopting this technology for protection as well. And some special project, as I said, these sensors could be used for very high currents, the DC current at aluminum melting facility. This is project of 2011 in Krasnoyarsk. You can well, actually, you cannot imagine, if you have never seen it, you would probably not be able to imagine the how large this current carrying bus. But believe me, the bus you can see, it's almost as as tall, as high as a person, just like a man. So it's around, I don't know, maybe 1.5 meter tall and the same wide. So it's really striking. It's an enormous amount of aluminium there, and so this current carrying bus, if you just try to dismantle it, you would probably go out of the work for several years. So, using this fiber optic technology, you can just wind the fiber optic around this bus and go on working. And there is some projects in progress. This is another aluminum melting facility in Irkutsk, and a very interesting project of digital substations, of several digital substations. It's called Pryzheyskaya. So the Elgaugol smart grid test bed, which is the Pryzheyskaya substation, is part of this smart grid project. You can see in the middle of the slide there's a picture, and it shows actually that there is 4 substations to be installed, and one of them is Pryzheyskaya 220 kV substation, and 2 3-phase sets of fiber optic current transformers will be used there. But what is special about this project is that all over this project, all substation would adopt IEC 61850 protocol as a main protocol for secondary system communications. So the characteristics for Pryzheyskaya substation is shown on the slide. So as I said, this you can see the range of primary rated current, which is from 400 to 1000 amps. The rated voltage is 220 kV, and the IEC 61859-2 interface is going to be used there. What's also special for this project, well, I don't think it's specific for India, but it's very, very important for Russia that the current sensor could work within the wide temperature range between -60 and +60 degrees Celsius. And finally, I would like to talk about the business development opportunities. There are several aims that Profitec foresees, and Profitec is going to product a complete solution for digital substation based on fiber optic instrument transformers. This means that, just as I said, Profitec has several partners on the territory of Russia that produce some different IDs with IEC 61859-2 support, as well as some special R&D and commissioning organizations. And the second prospective aim is expansion to foreign markets. There are 4 strategic partners, first of all, experienced in deployment of innovative projects and products in power, energy, and of course the clients for such kind of project. And we offer some 3 cooperation opportunities. First of all is pilot installations. It could be both the revenue metering and protection installations. The series installation as a logical continuation of pilot installation, and some special solutions could be developed, and transfer of technologies. So actually Profitec is interested in establishing some assembly plants for fiber optic CDs and VTs based in India. So this is basically all what I wanted to tell you today. maybe you have any questions, so then you are welcome with your questions.
Thank you, sir. I think there are quite a few questions. Mr. Irwin, you can ask your question now. Mr. Irwin?
Yes, sorry. Yes, I have one or two questions. One was concerning the outputs. I see that you talked about digital output, but at the same time you gave 1 amp or 110 volt outputs. Does that mean that you can also give analog outputs instead of digital?
Yes, it's definitely a possibility, but well, I must say that it is, you know, the preferable variant is of course the digital output, because it really provides, it really makes sense when you have a naturally digital signal and you use the digital output, and you don't have to make this, you know, transformations, several steps of transformation. Another point is that you cannot use this analog output for protection, only for metering. And just as I said, the preferable variant is of course the digital one, because, well, actually it makes sense in some, you know, in economical, the economically preferable variant is of course the digital one.
Okay, thank you. And what do you mean by frequency output or pulse output?
Okay, this actually is some specific installation for the for this DC current sensing, and this output was developed specially for this Krasnoyarsk aluminum melting facility, because they have previously had some sensors with this frequency output. What it actually means is that you have some special output signal, and the frequency of the output is proportional to the current flowing through the bus. Actually, this, you know, this is like the interface for some revenue meters, I would say. So they normally have this pulse and sometimes frequency output. So in this case, this device works almost like a meter for this DC current, but not really. It actually senses the primary current, and makes you some sample values of the current, but it has some special output signal.
Okay, thank you.
Does that make sense? Yeah.
Yes, absolutely.
Okay. Okay.
Any more questions, sir? Right. I think Dhanushri has a question. Dhanushri, you can ask your question now.